is the topic today is mainly about the principle of disease management strategies, and specifically prevention, control, and eradication. I would like to, within the next 45 minutes, to address the following issues or the following topics, mainly to have a differentiation between these three terms: the prevention, control, and eradication, because sometimes they are used interchangeably without knowing how these are, especially in their conditions and limitations, and in the strategies when they are used in animal diseases. And then I will have a little bit topic related to or presentation related to the herd immunity. It's becoming very popular these days, especially with the COVID-19, and even politicians now, they talk about it. So I thought maybe to give you some ideas about how it's been applied in, especially in animal population. And I will try to make it as much as possible attractive topic by giving some demonstration through existing case studies and programs as part of the exercise in that way. And then I will open it for a question and answer in the end. So when we talk about general strategies for disease management, and especially in a population basis, we are really talking similar to what I said in the title, in three terms: prevention, control, and eradications. So what would I mean by each of these terms? Disease prevention is mainly, as the name prevention, it comes to the exclusion of a disease, either from the unaffected animals or population, that they don't have the disease, or even within, if there is the disease in an individual in a population, to focus on individual or group, and then first line of defense against the disease in itself. So that's where I think it's the main issue to differentiate this term from the others. It's focused on individuals or groups within population, but also it's also the first line of defense against the disease. Disease prevention is usually achieved by exclusion of the agent from the area where it does not already occur. Okay, that's one way of achieving the disease prevention. So when you don't have the agent for the disease and it's in an area, then that's the exclusion. It can come that way. And usually that happened by the quarantine healthy or unexposed individual, or isolation of the unexposed individual in that terms. When we talk about protective specific animals in area where the disease already occurred, still it can be prevention. But mainly here we deal with quarantine of sick or potential exposed individual from the healthy individual. Again, here we try to prevent by the exclusion of from the other individuals or other animals. And this can be done either by quarantine, as I said, or by hygiene, in which we try to prevent from the agent to be spread to the healthy or apparently healthy individuals. Or it can come by immunization, which we will talk more in detail about that, or prophylactic treatments, which again, we will try to elaborate in a few slides from that. So what's the requirement for disease prevention? That's, I think I would like to call it mainly the limitations in that way, is prior knowledge about the agents. If we don't know about the agent of the disease, sometimes we call the etiology of the disease, especially when it comes to infectious diseases, then it will be very like difficult to say the prevention. That type of the knowledge could be about the survivability, could be if there is a vector involved in terms of the transmission and all of the other things. But also will require the biology, and sometimes we call the ecology of the disease, and such as like the incubation periods, the persistent in certain group, the shedding of the agents, and etc. And that's sometimes also related to what we like to call the infectivity of the agent and the pathogenicity of the agent for certain places. But also will require the ecology of the population, the dynamic of the host population here, in management, especially whether they are ins and outs and how they are moving in that respect, because they can affect the entire cycle. And that's probably you are aware of what we call the epidemiological triad, in which like the agent and the host interaction with the environment that will play role here. I thought like, well, I will give an example from what happened during the last few days is think about the prevention of the spread of lumpy skin diseases. Uh, this should be disease, not diseases. There is only one lumpy skin disease in Thailand. So at least what we read is officially there are some cases that of this disease coming to Thailand. So think about it in terms of like how you establish prevention. And the prevention here mainly to exclude the majority of the population, and here is actually mainly cattle population, or other ruminants can be also involved, is exclude them from the disease itself here. And you need to know about the prior knowledge about the agent, and you know this is a virus, and the arbovirus, it can be transmitted through like mechanical transmission through flies and other, okay, it can survive, okay, and the vectors, as I said, involved. So you consider that, you consider the incubation period of this disease, you consider who is resistant and who is not. To my knowledge, that all of the cattle population could be susceptible in that way. What type of shedding or what type of the virus and how the virus is spread is either by contact or through the, as I said, through flies and etc. You look on the ecology of the population, and in this way is what the movement of cattle and also the movement of the vectors here. And in that way that it can be associated all together in order to come with an effective prevention measures in that respect. When we talk about disease control are really all the measures used to affect the frequency of the or the impact of disease in a population. When I said affect the frequency is decrease the frequency of the disease, and that by itself will reduce the impact of the disease. This includes all the action that is being taken on sick through the disease or healthy individuals. So in that matter, actually, all the preventive measures are part of the controls, but not the opposite. Okay, so you don't have like every like control measure should be prevention in that respect. So you hear these days, at least in the United States now, is a lot of the media what they call flattening the curve due to the COVID-19. Flattening the curve, what they mean by that is reducing the area under the curve of the epidemic curve in that way. So it's not like to eliminate the disease, or is not only to prevent it, but to reduce its impact. Reducing the impact of a disease could be also reducing the severity of the disease, and in that by itself can reduce the impact in the long run. I'm going through these in a very general way, but then I will, maybe when I will talk about measurements or measures for the control and measures for the prevention, then you could see how it can be utilized in a real life situation. When we talk about disease eradication, eradication, I like to say, is equivalent to elimination. So that's how I will remember when I said prevention and I said is exclusion. Here, eradication is elimination. Uh, it's a mainly like that what need to remember, and the eradication could be local and even could be on a farm level, could be regional, or could be global. And it's a difficult in such way to do it because of the complexity of the disease ecology these days. And that's also because of our engagement through the management of diseases and management of livestock in that respect, but also related to the size of the population and related to the geographic area and also the number of political boundaries. I usually would say, well, is in terms of political boundaries, especially with infectious diseases do not respect political borders. And in that way, mainly the agent could be transmitted without considering the political boundaries. So you could see how it's really difficult when we talk about disease eradications, and especially when it comes to the global eradication. As majority of you would know, like with the major international efforts under the, I would say, like under the guidelines and the authority of the FAO, the one successful global eradication of an animal disease is done through the rinderpest. And I think that one we should be very proud because it was applying certain scientific findings and certain scientific tools that is being used in epidemiology to reach that level of the eradication. So disease eradication, it's a really practical goal for regional eradication, in my opinion. And mainly through the, like if there is a way to eliminate specific agent in such way like parasites, and the United States has done that, and also with some of the mycoplasma agents and other, and including some viral diseases. And that's where the elimination can be done on a regional basis, which is, in my opinion, a good starting point if we want to do it on a global issue, but as I said, is a stage by stage in that way. But I think also the natural barrier should not be necessarily considered or coincide with the political barrier. I like to say here, some islands manage to do the eradication for specific diseases, but mainly because there is a natural barrier. And in that way, it's really can be very helpful. And there are other diseases in which the eradication done on a regional basis because there was the political willingness from the neighboring countries that they can work together in that type of elimination of the disease. An example of that is screwworm in in North America and in Central America, and that all the way they manage the eradication now to reach the border with the South America and in Panama as a country. Sometimes the etiological agent can disappear. So that is, I like to say, well, the luck. And sometimes it can be naturally occur, and certain strain of influenza disappeared for a while, but then you need to be careful. Is that is really like long term, or is forever, or it can come back in that way. And sometimes is change affecting the life cycle of the disease, and that where it could lead to certain diseases that will disappear in that way. Like the one example I have is the uh, uh, swine vesicular disease, which virus, or they sometimes is called vesicular swine viruses, and they disappeared mainly because of the change in the management, which really affecting the life cycle of the disease in that way. And environment for sometimes is especially the natural reservoir, the vector, and the extinctions of the host. All of them, they kind of play a role in that respect. And a good example like that, it can work against the eradication when the vectors are expanding for vector-borne diseases, and then can lead to other diseases that or other host species that can be affected by the vector, such as what happening now in the United States with the some of the tick-borne diseases that can be spread in both humans and in animals. I giving this just mainly as an example of the how difficult is the eradication, and but also I want to emphasize sometimes by the luck that is the eradication will occur, and even on a, let's say, global basis, like the swine vesicular disease now is the virus is disappeared in at least in the, let's call it in land or in swine, but is the same like potential family of the virus that it can be transmitted at least in the some of the marine biology and that's been associated with the Pacific Ocean. I like to present this, and I really kept the reference from the Calvin Schwabe, the founder or the grandfather of the One Medicine that went later become and One Health. And in 1984, he listed in his book this type of what I like to call the direct action of disease management. And these, all of them could work either independently or one to complement the others in that way. I'm planning to go through some of them, in my opinion, that they are important and they are really like related to what currently we are facing, whether with animal diseases or also with the human diseases. I will also emphasize, since like you could see from the old like reference here, it's a real good way to say, well, how we can manage diseases in that way. Unfortunately, now with the COVID-19, we almost going back and try to utilize these, but it's been ignored for a while, and now it's almost like they consider it a new technology. I don't think is a new. All of these are being addressed before. So the first thing is I like to say is the diagnosis is a very important part in the prevention and control or in a disease management. It's essential in all the management processes, because without the diagnosis, we really cannot really take any other action, and the action will be limited or inadequate in that way. For disease management is mainly the early detection is very important, particularly in infectious diseases. So what we are saying is majority of the time we try to improve our technology to detect the disease as early stage as possible. And that's whether it's through a new lab technique or a new lab test, or even sometimes by improving our understanding of the disease manifestation by looking on their clinical signs as early as possible to do that and to do some good differential diagnosis, and allow other action to be taken as early as possible if we have a good diagnosis in that way. Uh, Clinical or laboratory diagnosis, I think, is very important and must understand and manage limitation of the diagnostic process. So here is where I really think is we need to go back, and especially in epidemiology, and recognize the added value from knowing what's the meaning of sensitivity of the entire diagnostic system or a laboratory diagnostic system, and what is the specificity of that way. That will come a very important and very essential when we try to declare an area or a region free from a disease, because the diagnostic process will be essential, especially to come up with like confidence in the negative outcome, or what we call negative predicted values of the entire system. Another, if you remember from the list, another disease management through the mass treatment. What we mean by mass treatment is the treatment, or what sometimes we call chemoprophylactics of the entire population, or entire like herd or entire clusters of animals in certain area. The underlying goal, or what is measured like we should consider, is we will have an impact on the shedding of the infection, which is what we like to call the likelihood of the infection or the spread of the infection, likelihood of the shedding of the agent itself, the amount of the shedding, and the duration of the shedding. Mainly, that's where the mass treatment will come in effect in that way. But required an effective and safe treatment as possible in that it can be used. I like to emphasize, and I will emphasize again when we talk about the vaccine, effective and safe treatment. And that must be also cost effective. The way I could see the mass treatment, it's been used or commonly used before, and even to a certain extent now in poultry, especially with poultry diseases such as the coccidioidomycosis. When they will diagnose that, then they will try to use a treatment that if can be being spread over all the population wherever it's being done, or wherever is the disease is diagnosed. The advantage is it will not require necessary identification of diseased animals to say, here is a diseased bird versus non-diseased bird. You can go and do it all together in almost like a mask, putting on your face and say, well, I give the treatment in that way. Can work for both clinical and subclinical cases. You don't have to say, well, yes, I will treat only those with the subclinical or clinical in that respect. However, mass treatment now is not so popular because of a lot of the disadvantage, mainly because some of the diseases or some of the group of diseases, the effectiveness of a treatment is not always available. And sometimes, especially in large animals, may require handling of all the animals. Like if I want to do, like for example, ticks eradication or a ticks treatment in cross all of the herds, then I have to, for example, with the availability of a vaccine against the ticks, then I have to inject every animal in the population with that in order to use it as a mass treatment. And that will require handling all of the animals. And maybe it's a really like related also to these two is there is a cost associated with it, and there is maybe a side effect. And the side effect, mainly, like I would like to say, is what is mainly related to the microbial evolution and maybe not suitable for multiple agents. The main reason now is mass treatment is not so popular for the reason of the evolutions and microbial resistance that can be done mainly because of the mass treatment. This is not only related to the antibiotics. For example, in Africa now, when the use of the dipping of for ticks, which is, in my opinion, mass treatment because they dip all of the cattle in that respect, and now is they are finding like the ticks are building a high level of resistance to the type of the chemicals that is used in that way. And of course, a lot of the other issues like it can be done in that way. The small strongyloids now is especially when they use ivermectin as mass treatment, is they are finding like strongyloids are resistant to the ivermectin, mainly because of this type of the, let's say, mass treatment or covers of all the animals, whether they have the parasites or not. I will go to the next one, which is mainly of like another disease management option is the quarantine. The quarantine is mainly what its main, it's, if I will define it, is to restrain a place upon movement of humans, animal, and plant, or goods in that matter, is like animal products that are suspect of carrying or are carrying the infection or being carrier or vehicle for the infection agents in that way. So quarantine is mainly, its main goal is to reduce the likelihood of effective contacts. So is allowing like, or do not allow the infected animals or the sick animals to be in contact with healthy animals in that way. That's how the quarantine means. It's quarantine could be international, as we can observe now, especially in the humans, as far as the COVID-19 and how they have like some issues with the international quarantines, or could be on a regional basis, or could be local. Okay, and I think is, let me start with the local. And in my opinion, several of the livestock industry or management, whether in dairies or swine or poultry, etc., they apply some way of quarantine, what they call isolation, when they have a new animals coming to the farm in that respect. So that's maybe an example of what we mean by that. But there is also a regional quarantine in which, like, some regions will not allow like animals to come without going it through like in a specific area. Like North America now, they have like some rules as far as, because of the FMD, on regional quarantine before they allow animals to enter to the North American countries in that way. And there is the international, and currently, like, and I hope not, I mean, if there is any type of suspect case with rinderpest, for example, since it is in global eradication from it, is then there is some rules of like how to apply the quarantine in that respect. It's the local offered, as we talked about, both in sick and healthy animals. For instance, like a dairy farmer will say, well, every replacement heifers, if they come from outside, then I will try to put them in an isolation pen until like certain time period before we allow them to come in. So it's not like related to the both to the only sick animals, but it's also healthy animals. Sometimes to reduce the both the cost and to be more effective in the quarantine, we do some screening process before we allow the quarantine, just mainly to eliminate sick animals from coming to the farm in that way, or at least to say, well, there is no reason to allow this because it's already diseased, so there is no reason to get it to the quarantine area. Uh, uh, and that's where I like to say, like, the large effort to exclude the sick animals and therefore only target healthy animals for the quarantine. And that is being like applied, for example, in the animal side with rabies. Okay, and one things I want to say about the quarantine, which is a really condition we need to be aware of, is the knowledge about the disease pathogenesis and the disease process. If we don't know how the disease behave in animals, okay, there is no reason to have quarantine, because the quarantine will have no end and would not be able to identify sick individuals in the population. That's the reason is quarantine has been very effective for rabies. And the reason is because we have sufficient knowledge about how rabies could be spread, what rabies incubation period, especially in the canine species, so and also in feline species. So when we quarantine them, we are really know at the certain time period, and this is what we are expecting. Otherwise, then the animal is healthy, and then that can be part of the populations that they are healthy and not having the disease. That's the reason I mentioned that, is that's where the quarantine can be effective. However, when other countries will say quarantine for BSE, bovine spongiform encephalopathy, that it will be not effective and is not really should be considered as an option to disease management, mainly because of the long incubation period, but also the potential for not showing any clinical signs in the animals that we are quarantining. So that, I think, it's a very important fact to can be considered. The advantage of the quarantine is mainly preventing introducing of subclinical cases, those cases that the oculate infection, those cases that we cannot see the infection and we usually cannot measure it in any type of laboratory test, but we need to wait for the disease to progress. And when the disease progress during the quarantine period, then we can see it. The disadvantage in that way is it's really impulsive and really like it's an enforced by its nature. When you said I quarantine, is usually that's an historically has some let's call it negative quotation that goes with it, and many times ineffective because it's imposed on freedom. And especially now when we said we are, and with the WTO, the World Trade Organization, allowing movement of animals with the certain conditions, then it could be like that way. It's not really sometimes convenience, especially with the frequent travel and the global economy, as I said, with the new regulations. So even though quarantine should be considered as part of the management, it's less likely, similar to the mass treatment, as part of what I would like to call is like now it's coming more common and more effective. Another disease management is sacrifice of disease or exposed animals. And that's where what I mean by the sacrificing here, remove the minority that they are ill to protect the healthy majority. So that's where is the sacrificing will come. So here we should have majority as healthy and then the minority as ill, then that method could be effective. There are different approaches to sacrificing the diseased animal, either by selective or by depopulation, which we will talk about it in the next few seconds. The selective here, you want to be very selective. You go and identify as much as possible the diseased animal, and you try to eliminate them. With the depopulation, you try to go and what's called the stamping out. You eliminate those exposed and those with the disease from the population. The main underlying goal, is again, it has a specific goal, is prevention of the exposure and eliminate the reservoir or eliminate the carrier or the source. Okay, all of them will fit under this type. So prevent the exposure. And prevent the exposure mean, again, you work with the contact rate but eliminate the reservoir in that respect. It's important and successful component of a disease surveillance, and especially in a in animal population, such as what we call test and slaughter, test for positive, test for ill, okay, and then slaughter those ill, and that is being used for bovine tuberculosis, is used also for bovine brucellosis, and being very successful in even eradication of these diseases from certain area or certain countries. It requires, if we use that, confidence in our positive outcome, whether it is one test or other or combining of tests. It has to be confidence in what we call, yes, it's positive, it's ill, and then in that way we will not sacrifice, let's call it, healthy animals in that way. As I mentioned, the examples is tuberculosis, bovine tuberculosis, bovine brucellosis, and even brucellosis in small ruminants, but also being addressed in foot and mouth disease, which is, I would like to give an example in the next few slides about this disease and the action we have taken in terms of the disease management. And this is very general, and is because the disease is extreme contagious in nature, and especially in the naive immunity population, we have to take some action. But I also would like to say is there is another fact related to the foot and mouth disease, which is stand, by the way, not only foot and mouth disease, is a stand for fast moving disease. Fast moving disease. So that's another reason, is because it's a contagious in nature, but it's also political disease. It's a trade disease that it needs to be considered. So it's because of that fast moving disease, we need to take a quick action and be decisive in that way. So most of the time we do the control movement of the animals. Again, reduce the exposure as much as possible. Sometimes we do depopulation, stamping out, and sometimes the vaccination, or sometimes the combination of all of those, and especially an endemic area in that respect. In the eradication of the foot and mouth disease, the stamping out will become almost like an important part, but it should be not apply in the early part of the disease when the prevalence is high. But that's where you don't reach that level of eradication. I refer you here to the PCP, the Progressive Control Pathway that FAO, and with the support of OIE, has established. In my opinion, they are really approaching disease management and eradication from a very scientific way, with a logical way in that respect. So when you apply stamping out, as I said, in the last part of the disease and for the eradication, you try to depopulate infected and those at risk or exposure in the area or in the country. It should be applied when the disease almost reaching like free from FMD, as they did recently in certain part of Brazil, or they did that also on Uruguay after they went through a very strong, I would say, campaign of vaccination in that respect. Okay, it's not really being done in another country like in UK, because in UK they were not free, but they did the stamping out over a lot of population, mainly because they want to maintain the eradication in that way. It's, as I said, is in a final stage of the eradication, can be very effective, and once the disease has been controlled. So here is the eradication will come in the end in that way. It is essential element in the eradication. I mentioned that before, but it also will require control of animals and the source of the virus exposure. That I think is very important, because then it will require removal the source of the infection. That's the reason, for example, like now in the United States, which is free from foot and mouth disease since 1951 or around that time, and what they are, at least according to the strategies, is stamping out will occur if the virus is introduced, but into only specific local areas. If they could not control and they could not remove the source of the infection, and the infection will be spread much higher, then they will do another control measures and not to consider the stamping out as the only measure in that respect for FMD. Just an example here. Slaughter of diseased or exposed animals is becoming like an issue, especially now with like looking for what is the other options that are available for us. But the advantage of it is an effective method for breaking the transmission cycle. It's almost like a surgeon to say, well, the best way is remove let's say like the tumor, and then that will take care of the source of the spread of the tumor in that way. So I like to call it as surgical procedure in that respect, is a rapid method for eradication, because immediately you can eliminate all of this possible, but maybe the only way to eliminate chronic or subclinical infection, as you know what happened with the bovine spongiform encephalopathy in UK, that where they use the stamping out and they use the exposed animals too, and mainly too because it's a chronic and also have some clinical infection in that way. The disadvantage is, again, you are imposing, you are acting with police authority in that way. And that is usually people are resistant to that, and especially the farmer. It will be very costly. It's usually applicable in a situation that not being, and this is where if you have a high prevalence, then you are really not only costly, but you are sacrificing a lot of animals that does not need to be sacrificed. So it's not really applicable in that situation. When you don't have a replacement, when the replacement is unavailable, and in that way, that's what happened in Turkey when they had, like, they tried to eradicate bovine leukosis, or sometimes it's called the bovine leukosis, or BVR, the retrovirus what they call infectious bovine leukosis. That's the right terms now is used. And when they did that, what that happened is they depleted all of their dairy population, and then they had to go outside and buy more cattle in that way. And where sometimes we need to be very careful when economically or socially unacceptable. United States, it tried to use the stamping out or slaughter of disease in Haiti because of the, at that time, of the scare from the classical swine fever, and in that way was really like socially and culturally and economically was not really get good advantage in that respect. And slaughters cannot be applied to all species, especially when you deal with wildlife or fish, and in that way also with rare species, then you need to be careful in that respect. Currently, for example, is like, as you know, like FMD or deer and cervets altogether are susceptible to FMD. So the issue here is if FMD will enter to an area in which like they have high population density of deer, what it can be done. Currently in Europe, they with the African swine fever and with the wild boars, they are really trying to eliminate the disease, but they are also eliminating the wild boars as much as possible, which is not very successful, but that's another issue here. And it's very difficult to sell to the public by saying like you are applying some like an issue and like to kill animals. They don't like that. And you need to be very careful by sacrificing false positive animals. These are healthy animals, but they are showing any type of either by the test or by some other methods like clinical signs that they do have the disease. So that another issue that's being addressed, especially with the bovine tuberculosis in some countries in which like they depends on the one test, let's say caudal fold, and then they send the animals to the slaughterhouse, but majority of them are false positive. And there is also the impact on the environment when you try to do that, like in countries like, or like in a state like Colorado, in which like is the under the surface water is very shallow, and then what you do with the animals in that respect. And finally, there is also the animal welfare issue and the social pressure in that respect, because that, of course, as you know, like it's happening in Europe in that respect. Mass immunization. This is what it means is the various method we do for improving immunity for a specific disease agent. And that could be done either innate or versus acquired. The innate is mainly is like when you use, for example, what is the autoimmunity, which is like you take, like they do with the cowpox, they take like one lesion and then they try to inject it in other animals, and that can develop some immunity. And but also it could be acquired, and acquired through maybe a products that it can be used. It could be active, which is directly to the host, directly to the animals, or could be passive, as we do with especially with cows. We give the vaccine to a pregnant cow with the hope like some of the vaccines will be transmitted through the colostrum to the calves, etc. And mainly the underlying here is decreased susceptibility. This here is not about the contacts. Here is decrease the susceptibility. And then there is two terms, whether is mass immunization, in which like you immunize all the populations, but sometimes we use the target immunization, in which like you focus on a specific population, either because they are high risk or because they are also more movable, which is still high risk, etc. in that way. The mass immunization, that's usually, for example, what we use with FMD in countries in which like FMD is still endemic, is target immunization. Sometimes like it's like what in United States, for example, with the bovine brucellosis, in which they use RB51 for a specific target population, and mainly intensive dairy farms, because that's where we like to call it the high risk group for getting and spreading the bacteria. Mass immunization is the most common method for protection, okay? But it has almost like a double-edged sword. It has good and bad things. And why I say that is because vaccination is considered by the public is almost a silver bullet. Like it can treat, or it can, is the solution for everything. And that's where I think it's need to be addressed in that way. And sometimes we take it like as a granted, like if I've been vaccinated, my animals, that means they would not have the disease. That's not correct. Why? Because if every vaccine should be addressed from both the safety and the efficacy. Safety is very important, as will probably some of you aware, like why we don't use, for example, a live virus vaccine for avian influenza for poultry. Is not because it's not effective, but is also because of its potential for contaminating the environment, and also to be able to mutate and become virulent and become like either not only for the poultry, but also to the humans and other animals. So here it has to be addressed both from safety and the efficacy in that way. Routine vaccination, an example here is what we do, as I said, for example, with the brucellosis, and especially with the eradication program, even before the RB51, strain 19 was used, and the disease was, or bovine brucellosis was eradicated from specific countries by using the vaccine on a routine basis, but also with the elimination of the infected animals or susceptible or suspect animals, such as what we call test and slaughters. The FMD eradication. Uruguay, South American country, is a good example, and also Brazil recently, for how they could eradicate the FMD from the country with limited depopulation or stamping out by just using the vaccine in that way. But it was effective because the vaccine is effective. Rinderpest. Rinderpest is a really good example for a global eradication of the virus, okay? Well, because there is a very effective vaccine for it, still there, available, and also safe. So because of those is the achievement through the eradication occur in that way. So vaccination has a lot of good things, but as I say, the bad thing is mainly like is we should not depend on it as the only way to managing diseases. The advantage is the ability of the resistant individual to move about. So currently, for example, I'm using a human example now with the COVID-19, and then some countries are requiring to have vaccination before they allow people to move. And it's very appealing to the consumers, very appealing to the producers. When you said I go and vaccinate, and they think is there is good protection, and it's true actually. And you may require less doses of the protection as compared to the chemoprophylactics, in which like you go and you waste a lot of chemicals or drugs in that way, because here you give the vaccine directly and to the population. The disadvantage is lack of proven products. Sometimes, and especially like probably you hear, like now in China, when non-approved products related to the ASF in using what it's called homegrown vaccine for ASF, African swine fever, it can be really leading to certain, I would say, negative impact, like especially now circulating low virulence of this virus, and that it cannot be detected by the conventional method of the detection of ASF. We should also think about the imperfect protection. That's what I like to say is sometimes if the vaccine is to protect from a disease, that doesn't mean we will have a sterilizing immunity. Means like that we will not get the infection. Currently, with some of the issues we have been discussed, especially with the new development about the availability of the ASF vaccine, they are thinking about like is mainly protection from a disease, but would not protect from the infection itself. And also there is another thing is the duration of immunity. That's the reason, for example, we use every 6 months the FMD vaccine, because we know it will not stay for long time period. And sometimes, again, that is the usually require handling all individuals. And that I can tell you, it has some negative effect in that respect, and especially like when the example I have with the Brucella melitensis and the REV1 as a vaccine that it can be used in the conjunctiva, in which like one country in Europe, they have very high level of melitensis in their sheep. So with the like the veterinarians will go and give a drop of the vaccine in the eyes, and in that way, first of all, is you need to have the handling of all individuals, and it led to the high infection rate of Brucella melitensis in among veterinarians, because they were not taking a precaution, as you know, Brucella melitensis vaccine, the REV1, is a live bacteria, and that led to some cases. So it has like some, I would like to say, the disadvantage, not only on the individuals you are giving that, but also on the user or the provider of the vaccine. I like to say, well, is when you developed a disease management program, you may follow the HACCP, the HACCP procedure. HACCP procedure is the hazard analysis critical control point. Is usually used a lot in the, what I would like to say, in the food safety and the meat inspection. However, it has really, the principle is could be applied to any disease management in that way. So what you do is try to conduct a hazard analysis, identify the critical control point, whatever these critical control points, that will come from knowing the pathways of the disease. You knowing the disease pathogenesis on a population basis. That's where you identify the control points. You know from the life cycle of the disease. You look for the weakest point in that respect. It's established very critical limit associated with each to try to identify what is going on in each of these critical control points, and then establish a monitoring for the critical point, so you can intervene in the right environment, and that will require corrective action. The action could be one of the management items we mentioned before, but all of this will require a good record keeping procedure, which means you have to maybe think about how you incorporate that in the overall surveillance system in that respect. And establish again some verification for the HACCP system in a working, and it has to work correctly in that environment in a very comprehensive way. This is a very general things, but it can really apply it, and you customize it to what disease you need to consider in that respect. But from practical standpoint, and that's where actually my message, in my opinion, is any type of management of diseases will require early detection, decrease the contacts, okay, increase the resistance, and eliminate the source or the reservoir. So these are the main direct actions you need to think, and you could apply it to any of the diseases in that respect. Okay, I move now, and I think I have maybe a few minutes more. Is that correct, Dr. Sith?
Yes, but the Q&A also after this.
Yes, okay. So I move to a different topic, is about the herd immunity and versus host immunity. As I said in the beginning, I feel like this is an important component now because everybody is talking about it. It's not something new. We know this, but it's mainly to show what are, I would say, misunderstanding or the right concept of this issue. When we talk about host resistant against infectious agents, we are really talking about two types of resistance. This is host, individual host, okay? So either biological resistance, what we call host immunity, for example, is I am resist to, let's say, smallpox, okay? I'm just giving an example here, okay? Or it could be circumstantial resistance. The circumstantial resistance could be lack of contacts, okay? That means there is no contact with infectious agent that it lead to that, or it could be through herd immunity. So what's herd immunity here? I'm moving now from individual basis to the population. Herd immunity is in individual depends on the characteristics of the population where that individual is there. So when we talk about herd immunity of a dairy cow in Colorado, okay, depends on the dairy population in Colorado and for that disease, okay? So I go back to say is a dairy cow in Colorado has a resistance to FMD because of circumstantial. The circumstances is lack of contacts, but also it's the cow is part of a dairy population in which they have high herd immunity for FMD. Why I say that? Because when you talk about herd immunity, is mainly related to decrease the probability of adequate contact that require for transmission. So the definition of it is the likelihood that an affected individual transmits the infection to average susceptible individuals in that population, okay? So herd immunity is a concept, and this is where I really would like to say, is a concept it's not like you could measure it by itself except through what is called the R sub naught, which I have a few slides in the end. So it's really affected by the circumstantial and the biological resistance for its member. So the next slide is mainly to show you the scenarios for what we mean by herd immunity. So if I will bring one infected birds into a population of all of them are equally susceptible, okay, but they have no immunity at all, no herd immunity, then I'm expecting that individual bird will be able to spread the disease much higher than if the same bird I introduce it to a population of birds, okay, in which some of them are immune, some of them. So that degrees here on this population of the spread will be much higher as compared to this one. Now, if I increase the ratio of the immune population, okay, to make it like the majority of the populations are immune, or let's call it non-susceptible, then that bird will not be able to spread the infection the same way as the first one or the second one. I maintain here to say here is decrease the susceptibility. So the ratio here of decreasing the susceptibility, it can be presented as you could see from just looking on the red dots as compared to the black or dark dots here. Reduction in the susceptibility most of the time is done by what? By immunization, but is not necessary by immunization. I could increase susceptibility, for example, here by introducing of birds that they are not susceptible to whatever the infection here, okay? And that can come through like different breeds, or I introduce like genetic modified birds that it can be resistant and so on. So here what we call with this circle, we said it's the herd immunity is high. Herd immunity here is like minor or whatever. And here is no herd immunity, okay? So I don't like the idea to say, well, here is like we have 70% herd immunity. That is really not like I would say is possible estimates, is mainly is a concept in that respect, okay? So the factors affecting herd immunity, there's mainly two composition for herd immunity. The number of susceptible individuals, think that way, susceptible individuals, okay? And the contact rates, sometimes we call effective contact rates. The frequency of the contacts, how often my birds will contact with the other birds, the how adequate means like for how long, okay, and what type of contacts. Is it mainly like is through let's say like breathings, or maybe like through eating the same feed or whatever, and which individuals, like in terms of the host characteristics, is by age, by color, or by purpose, and so on. All of them will play rules in the contact rate. But in the end of the day, there are two compositions: number of susceptibles and the contact rates. In my opinion, all of the disease management strategies are targeted to manipulation of one or of the two of these compositions. Either we manipulate the susceptible individuals, or we manipulate the contact rates, or both. Every management we mentioned, if you think about, will fit within these two. So the herd immunity concept is a very important to determine the management of a disease in a population in that way. So, but herd immunity bit also will be related to the ecology of the disease. For example, herd immunity for for influenza virus H1N1, okay, is different than for poultry versus pigs versus a human, okay? And the reason because it depends on the ecology of the disease, which is composition of the agent, the host, and the environment in that respect. So that's where I think is the issue will come in the picture. That's the reason is like with the COVID-19, the emphasis on herd immunity, mainly because this is, we are dealing with naive and in terms of immunity of a population, because this is a new virus. And we tried, like when we said the reduction in or wearing mask, what we are doing, wearing mask is mainly reducing the contact rate. When we said go and vaccinate, the main reason is to decrease the number of susceptible individuals. So here where the issue like the combination of the two will come in the picture. So herd immunity is, in conclusion, is a resistance of a group of animals to the invasion and the spread of infectious agents. But it's also because it's the collective immunity. It's not on individual birds or whatever. It's the collective immunity in that way. And the application here is mainly in vaccination level for disease eradication. So here is where it's being addressed, of course, way back with the rinderpest, is you don't have to vaccinate 100% of the ruminants in order to reach a high level of herd immunity. And by the way, herd immunity is used in both humans or public health and animals, but is originated because of the rinderpest, because of the way back in when the scientists start to figure out how to control the disease, and they found out that it's not necessary to vaccinate all the herds in order to reach a level of protection. And that's where the terms herd came in the picture. So I like to stop here because the rest of it is I'm talking about the, I have a few other slides related to the R sub naught, okay? And that's the concept of what I like to call about the reproductive rate, which is an indirect way of measuring herd immunity. The reason I'm stopping here because of the time, but also I think is maybe will be very boring for some of you to know about the R sub naught. I will encourage you to review these slides. As I said, there are 6 slides. And if there is any question about those, you let me know in that respect. I prefer to give more time for the question and answer in that respect.
Thank you very much, Dr. Salman. And you end up with the concept of the herd immunity that actually is the word for veterinarians, I think. But we heard a lot during the COVID-19 for this time. And we have about 5 minutes for the Q&A, and I will let Pam help for raising the questions. from the Q&A and chat box, please. Thank you.
Thank you so much, Dr. Sid, and sorry, Mo, because I understand that you would like to answer, all the questions, but we have a very limited time. So I will entertain you with some questions. For example, there is a questions about eradications and eliminations. For example, if the rabies still, occur in the wildlife, even though, there is no rabies in companion animals in some specific area. So would we call eradication or eliminations of the rabies or not? The second things related to eradications and elimination as well. So sometimes if we like to eliminate the pathogens, it might affect the ecological cascade. Some pathogen may be within the, ecology thing. So could you please respond to these two questions?
Well, let me answer the first one because I'm not really clear on the second question. I'm glad they ask about the eradication of rabies, and especially when the engagement of the wild species. Eradication or elimination could be related to a specific species. Okay, so when we said rabies eradication in dogs, okay, then that doesn't mean that's where Europe went through first, okay? And then they said, now we need to focus on eradication of rabies from, let's call it wildlife. Then they focus on foxes and other canine species. So that it depends on how they address and how they qualify that. For example, now in the island of Hawaii, rabies is eradicated or rabies is not there. Or in that matter, actually, let's think about Australia. Australia doesn't have rabies now being addressed, okay? However, if you think carefully, is they don't talk about bats, that they could move between the continents. However, what they do, they test those, okay? So if they want, and let's hope not, but let's say tomorrow they will get rabies coming with bats, okay? If that will come, they still can't say we are free from rabies in our domestic animals, and that it could happen. And the same in Bali, because I think that's a good example about rabies. In Bali, to my knowledge, it was when rabies enters is only in dogs. So you didn't see it in other animals or domestic animals, as compared to what we see in Brazil or United States. Now, the second question is, I did not follow on.
Yeah, I can repeat it again, Mo. Actually, the full question is: as all elements, both biotics and abiotics, in the environment have their respective roles to play, even as specific pathogens, how can we actually elaborate the eradications or eliminations concept into disease management, as eradications of a pathogen could create another harmful ecological cascade?
That's a very good question. And I don't have I would say, the answer to all of that. That's the reason I feel like our environmental assessment should be part of it. I will give an example here is there are a group of scientists who believe they can eradicate malaria, okay? And the eradication of malaria by destroying the vector, destroying the Anopheles. This is an example here. However, there are other scientists, they would say destroying the Anopheles will interfere with the wildlife ecology because there are so many other animals and the plants, etc., will depend on those, okay? So that's where I think is the balance is needed. That's where I don't like this term eradication, because I feel like nature is more powerful than us. It's better to live in harmony and to live in balance. And that means we need to control diseases instead of to say eliminate them, because some of them they serve the purpose. And one of the purpose, and this is not a joke, but one of the purpose is job security for us.
Yes. Okay, Mo. Thank you so much. I may walk you through another questions. Maybe the last questions. Link between two questions about the lumpy skin disease. As you know that in Thailand we face with the lumpy skin disease and related to the the vector. What would you recommend to actually can control this vector as well as the disease in Thailand?
Well, that's again is a very valid and up-to-date question, in my opinion. This disease is, how EU treated that disease, vaccination. Okay, and they went, and by the way, in terms of those who are involved in policy, it's the first time in European Union to come up with a different alternatives how to deal with what they call with the transboundary animal disease, because their idea is to do stamping out. Okay, that's where with transboundary animal diseases, then they had to get approval from ministerial level to introduce a vaccine for what is called exotic agent, exotic virus. And they monitored the vaccination and it did work. In contrast, and that's what I think you need to have good background. In Israel, when the disease came in Israel, this was maybe 6, 7, or 8 years ago, Israel looked on the vaccination, okay? And they look on stamping out, but they figure out both of those will be very impractical for their situation, mainly because they said this is a vector-borne disease and we cannot control our neighboring countries. And that's where they decided we can live with it and try to limit the spread of it as much as possible by quarantine some of the farms and work with the animals. Given the fact lumpy skin disease is not really killing the animals, is mainly an ugly face, ugly skin you see on the animals. So if you will ask me about Thailand, I think since it is early introduction, I will try to limit the disease in an area and using some vector-borne control strategies. Vector control strategies, not vector-borne, by trying to eliminate from the area as much as possible the vectors and the flies.
All right, thank you so much, Professor Salman. And I think we don't have more times for you to answer the rest of question, but I think we try to consolidate all questions and send to you by email, and in case you can respond to those questions.
Please do that, and I